Hi, and welcome to the 5th video in our water management series. This time I thought we ought to talk about cross-connection control and backflow prevention. Now some of you may not have heard of these at all, and some of you may have some idea of what they mean. So let me start with an explanation of what cross-connection and backflow are all about. To get you started, let's look at some definitions. You'll need them to understand what a cross-connection control program is and why you need one in your town. Cross-connection is a connection of a potable water system to a non-potable system or a system of questionable water quality. And by the way, potable water means water that's okay to drink. For example, your town's water system is almost certainly connected to a boiler that is part of a school or other large building's heating system. That is a cross-connection, and many times you have to have them. The boiler has to have water, so you automatically have a cross-connection. Now, backflow is the reversal of the flow of water from its normal or intended direction of flow. Let's use animation to show how all of this works. In your water system, backflow can easily be caused by a break in one of the water lines or by the fire department turning on a fire hydrant to fight a fire. When that backflow happens, a cross-connection that isn't controlled will allow the bad water to flow back into the good water in your water system. Here you see the water that's going to the school start to flow backwards. If there is an uncontrolled cross-connection on the school's boiler, then the boiler water will flow back into the water system. The way to stop backflow is with a program you set up to control the cross-connections. If the cross-connection doesn't allow the backflow, then your drinking water stays potable. Other examples of non-potable water is the water used in a dishwasher or a sink. Actually, there are lots of examples of non-potable water, and we'll talk about many of them as we go along. Non-potable water backflowing through a cross-connection into your water system is potentially quite dangerous, and it could make your water customers very sick. There is no question that you need a cross-connection control program because backflow from cross-connections occur every day in this country. There are many examples I could show you of potential backflow situations, including in a hospital, a mortuary, a nursing home, or a farm co-op. But let me give you a couple of simple everyday examples of backflow and cross-connection. Follow me. Fred's working on his lawn today, and he agreed to help me with this. Let's assume that you've decided to fertilize your lawn like Fred's doing here today using one of those simple hose applicators. Now let's assume that 2 blocks away the fire department is fighting a fire, and the fire department uses so much water to fight the fire that the pressure in the water line here is greatly reduced. Morning, Fred. Nice day for yard work, isn't it? Thanks for helping me out with this video.
You bet, Jim, no problem.
Now, you wanted to put some fertilizer on your lawn today using one of these on-hose spray units, right?
Yep.
And then I see you're going to mix the fertilizer in this bucket and then fill the sprayer from the bucket. Now, let's assume that Fred leaves the hose hanging in the bucket when he goes to turn on his water. This is a simple cross-connection possibility. Non-potable liquid in the bucket meets the potable water system in the hose. Now, let's also assume that Fred has opened his spigot and the water starts to fill the bucket. After a few seconds, the fire department begins to fight the fire and pulls a tremendous amount of water out of the water system. This might create a backflow in the system, and let's use our animation to show how this might all work. Potentially, the water in this hose can start to be sucked backwards. This could easily pull the contents of this bucket into the water system. The backflow created by the open fire hydrant pulls the water backwards, sucking the fertilizer back into the hose and eventually into the water distribution system. So, the backflow created in the water system by the firefighting and the cross-connection between the hose and the bucket contaminates the water system. But you can prevent this problem with a solid cross-connection control program. A simple backflow prevention device like this one installed on the spigot at the house prevented this water from going backwards at the spigot. Thanks, Fred. The lawn looks great. Okay, now that you know what cross-connection and backflow are, you need to know what you can do to prevent contamination due to cross-connections and backflow. To solve this problem, we actually control the backflow part of the equation. You see, cross connections are actually part of our plumbing and water systems, and we simply can't eliminate them altogether. For example, the average toilet has cross connection. As you can see from this diagram, the potable water enters the toilet tank, and if backflow were to happen, the non-potable tank water could flow back into the potable water through cross connection. However, modern technology has given us new tools to prevent backflow in our water system. They are called backflow prevention devices and assemblies. There are two basic types: reduced pressure or a double check valve. These backflow prevention assemblies are testable to ensure they are working right. Placed at the site of a possible cross connection, they can protect the plumbing system from contamination. Placed just downstream of a water meter to an establishment, they can protect the public water system from any contamination that may occur within the entire establishment's plumbing system. Let's review what we've covered today. We've talked about what cross connection and backflow are and how they can occur in your water system. We've given you guidelines on the best way to design and implement a cross connection control program, and we've given you some specific tips on steps you can take to be sure you're ready to start the program, and then, once it's up and running, how to keep it running smoothly.